GATE 2012 Civil Engineering Question 5. The following statements are related to bending of beams. 1. The slope of the bending moment diagram is equal to shear force. 2. The slope of the shear force diagram is equal to the load intensity. 3. The slope of the curvature is equal to the flexural rotation. 4. The second derivative of the deflection is equal to the curvature. The only false statement is the four options given are A1, B2, C3 and D4. The relevant NPTEL reference has been listed. So if there is a beam whose deflection is y, so dy by dx is given as the slope, that is theta. If we differentiate it once more, it becomes the moment. If we differentiate this once more, that is d3y by dx3, it becomes the shear force. And if we differentiate it one more time, that is d4y by dx4, it becomes the rate of change of load, that is the loading rate. It can also be seen that if we have differentiated moment with respect to x, we are getting the shear force. If we differentiate the shear force with respect to x, we are getting the loading rate. Another key thing to be noted is that moment is equal to EI d2y by dx. So by EI will be equal to d2y by dx2, which will be equal to 1 by r from the simple bending equation. 1 by r is the curvature. So the slope of the bending moment diagram is equal to the shear force. So as we saw in the previous slide, dm by dx is equal to the shear force. So 1 is correct. The slope of the shear force diagram is equal to the load intensity. So as we saw, dv by dx is equal to the loading rate. So option 2 is also correct. The third one is the slope of the curvature is equal to the flexural rotation. So this is not correct. And the second derivative of the deflection is equal to the curvature. So as we saw, 1 by r, that is the curvature, is equal to d2y by dx2. So the second derivative of deflection is equal to the curvature. So 4 is correct. So the only option incorrect is 3. The only false statement is 3, that is option C. The relevant NPTEL reference has been listed.